Hello viewers, welcome back to my channel Shraddha's Physics. So in this part we will see the complex form of the Fourier series in the arbitrary period. Okay, so here we will discuss in the arbitrary period. Now let us begin our topic. So from the previous lecture we have considered that for the arbitrary period we have to take suppose any function, that is any variable z, that is equal to pi x by L we have to consider. Okay, or we can write this x will be equal to, simply this will be Lz divided by pi. Okay, so now we can say that when z value equal to plus or minus pi, then we can say that the value of x will be equal to plus or minus L. That is when this z lies between minus pi to plus pi interval, then x value will be minus L to plus L. So in this expression also you can put and check. That is, if we will put z to be minus pi, then this pi get cancelled, this will be minus L. And when you will put z value to be pi, this pi get cancelled, you will get simply L. Okay. And also we have considered, since this z equal to pi x by L, we can write f of z equal to f of pi x by L. Since this pi by L is your constant, we can simply write it as f of x. Okay. So now let us write the expression for the complex variable, that is when we have considered in the form of the complex, this series can be written as sum over n equal to minus infinite to plus infinite the Fourier coefficient Cn exponential I n j. This is in terms of the complex series. We can write the value, that is when z lies between minus pi to plus pi, we can write like this. And here the coefficient Cn, that is equal to 1 by 2 pi integration from minus pi to plus pi. This is f of z, this is plus pi, f of z exponential, this will be minus I n z dz. Okay, and now if I write this is c minus n, that is simply this n value goes to minus n. This is 1 by 2 pi minus L to plus L. This will be f of z exponential I n z into dz. Now if I will consider for the arbitrary period, so this is for the minus L to plus L interval. But if I will consider for the arbitrary period, so let me write in arbitrary period, so this function f of z can be written as in terms of f of x, that is equal to this limit value. So let me write properly. So this is your f of x equal to summation over n equal to minus infinite to plus infinite Cn exponential In, in place of z I will write pi x divided by L. So this is the series expansion of the Fourier in terms of the complex. And similarly we can write the Fourier coefficient Cn will be equal to 1 by 2 pi integration from minus L to plus L. This will be f of x, and here this term, here I am writing this term, this will be f of x exponential minus In, in place of z I will write pi x divided by L. Since z equal to pi x by L, we can write dz will be equal to pi by L into dx. Now if I write this one, this will be into pi by L into dx. So here pi get cancelled. So that is equal to Cn equal to 1 by 2L integration from minus L to plus L. This is f of x exponential minus In pi x divided by L into dx. Okay, so this is the Cn. Now we can calculate also C minus n coefficient. Now we can write C minus n equal to, simply you can replace this n by minus n, or you can write from this expression also. So let me write from that expression, that is 1 by 2 pi integration from minus L to plus L. This is f of x exponential minus In pi x, that is in z term, you can see here this term 1 by 2 pi minus L to plus L integration. In place of f of z I will write f of x. This will be exponential, this will be plus In, in place of z I will write pi x by L. This is your In pi x divided by L, and in place of dz I will simply write pi by L into dx. So this will be into pi by L dx. This pi get cancelled, that is equal to 1 by 2L integration from minus L to plus L f of x exponential in pi x divided by L into dx. But here you can see that in the Fourier series expansion, simply if you know the value of the Cn, you can directly calculate the Fourier series. So this is just the method. So just here we are writing Cn as well as C minus n. You can see here in this part we have represented this Fourier series, that is in this black one. We have represented this in when this z value lies between minus pi to plus l. But in this part here we have represented the Fourier series when it is lies between the arbitrary interval minus l to plus l. Okay, so this is our function, that is f of x equal to summation over n equal to minus infinite to plus infinite Cn exponential in pi x by l, and Cn value equal to this much, that is Cn equal to 1 by 2l integration from minus l to plus l f of x exponential minus in pi x by l into dx. So by using this expression you can calculate, in the next video we will see, we will calculate the complex form of the Fourier series. Suppose a function is given f of x equal to exponential any form, that is let me take exponential minus x. So for that we have to calculate the complex Fourier series of this complex number. So simply first of all you have to calculate Cn, that is in place of f of x you have to put exponential minus x. Here if the limit is given minus 1 to plus 1, simply you have to put the value of minus l as well as plus l to be minus 1 to plus 1. So after calculating the value of Cn, you have to just put in this series, that is Cn, you have to put this value, that will give the Fourier series. Okay, so in the next video we will calculate for this. So this is all for today. If you have any doubt, can ask me in the comment section. Thank you all.